Hello students, welcome to this lecture 1 statistics. So in this lecture we will discuss introduction and mean of group data. So in class 9 there you have studied the classification of given data into ungroup as well as group frequency distributions. Okay, and you have also learned there to represent the data pictorially in the form of various groups such as various graphs such as bar graphs, histograms, okay, and including those of varying width and frequency polygons. So in fact you went a step further by studying certain numerical representatives of the ungrouped data, also called measures of central tendency, namely mean, median and mode. So in this lecture basically we first of all introduce statistics and then we'll study mean of group data. Okay, so in this chapter we shall extend the study of these three measures, that is mean, median and mode, from ungrouped data to that of group data. So we shall also discuss the concept of cumulative frequency and the cumulative frequency distribution and how to draw cumulative frequency curves called ogives. Okay, so that we'll discuss in this lecture, in this chapter. Okay, so here we first discuss mean of group data. Okay, so mean, that means average. Okay, so the mean or average of observation, as we know, is the sum of values of all observations divided by the total number of observations. Okay, so first of all you have to sum one observation that you have given, okay, and then you have to divide it by the total number of observations. Then you will get sum of the then you will get the mean or average of the observations. Okay, so from class 9th, recall that if x1 x2 x3 xn are observation with respective frequencies f1 f2 f3 fn, then this means observations x1 occurs f1 times, x2 occurs f2 times and x3 occurs f3 times, and so on. xn occurs fn times. So now the sum of values of all observations f1 x1 plus f2 x2 plus f3 x3 plus plus fn xn, okay, and the number of observation is f1 plus f2 plus plus fn. Okay, so sum of all values of observation is basically equal to f1 x1 plus f2 x2 plus f3 x3 plus plus fn xn. Okay, and total number of observation, this is equal to f1 plus f2 plus plus fn. Okay, so here, so the mean is denoted by x bar, mean or average of the observations is denoted by x bar. So the mean x bar of the data is given by x bar, this is equal to f1 x1 plus f2 x2 plus plus fn xn divided by f1 plus f2 plus f3 plus plus fn. Okay, so recall that we can write this in short form by using the Greek letter summation. Okay, capital sigma, this is actually summation, okay, which means summation. So that is x bar, so x bar or mean of the data is equal to summation fi xi, where I is equal to 1 to n, divided by summation fi, where I is equal to 1 to n. Okay, so here total observation, sum of observation, this is f1 plus f1 x1 plus f2 x2 plus plus fn xn, and we can write in short form by using this Greek letter summation. Okay, so summation fi xi, where I is equal to 1 to n, and total number of observation is basically equal to summation fi, that is f1 plus f2 plus f3 plus fn, can be written in the short form in the by using the Greek letter sigma, okay, capital sigma, that is summation fy, where I is equal to 1 to n. Okay, so mean or average of the data is equal to summation I equal to 1 to n fy xi divided by summation fy, where I equal to 1 to n. Okay, so which more briefly is written as x bar, this is equal to summation fy xi divided by summation fi. So if it is understand that I varies from 1 to n, okay, so we can write more briefly the mean or average of data by x bar is equal to summation fi xi divided by summation fi, where I varies from 1 to n. And now let us apply this formula to find the mean in the following example. So now we will explore some examples. Okay, by using this formula we can solve that example. Okay, so first example here, the marks obtained by 30 students of class 10 of a certain school in a mathematics paper consisting of 100 marks are presented in table below. Okay, and find the mean of the marks obtained by the students. So marks obtained, that is denoted by xi, and number of students, that is denoted by fi. Okay, so x1 is here 10, f1 is 1, x2 is 20, f2 is 1, and x3 is 36, f3 is 3, and x4 is 40, and f4 is 4, and corresponding values are given to us by this table. Okay, so here recall that to find the mean marks we require the product of each xi with the corresponding frequency fi. Okay, so let us put them in a column as shown in this on this table 13.1. so here mark obtained, that is denoted by xi. So marks obtained 10 when number of students fi is 1, and fi xi is equal to 10 into 1, that is 10. Okay, when marks obtained 20, the number of students f2 is 1. Okay, fi is 1, and now fi times xi is equal to 20 times 1, that is equal to 20. And when marks obtained xi 36, and then the number of student fy is 3, then fi times xi, this is equal to 36 times 3, that is equal to 108. Okay, so here we can write more marks obtained and number of students and fi xi. Okay, so we can calculate for other. So you can see here, so here total summation fi, this is basically equal to f1 plus f2 plus dot 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 plus fn. Okay, so here summation fi is 30. Okay, so you can, if you add all the values of number of students 1 1 3 2 3 4 3 2 4 4 1 1 1 1 1 2 3 1. Okay, so you get summation fi, this is equal to 30. And if we add summation if we add wall fi xi, then you will get 10 plus 20 plus 108 plus 160 plus 150 plus 112 plus 240 plus 280 plus 78 plus 80 plus 176 plus 276 plus 95, and the total summation fi xi, this is equal to 1779. Okay, so summation fi is 30 and summation fi xi, this is equal to 1779. And now the mean or average of marks obtained x bar, this is equal to summation fi xi divided by summation fi. Okay, and here summation fi xi is equal to 1779 and summation fi is equal to 30. Okay, so x bar, this is equal to 1779 divided by 30, and this is equal to 59.3. so therefore the mean marks obtained is 59.3. okay, so the mean marks obtained is 59.3. so in most of our real life situations, data is usually so large that to make a meaningful study it needs to be condensed as group data. So we need to convert given ungroup data into group data and devise some method method to find the mean. Okay, so in most of our real life, their real life situation data is usually so large. Okay, that is why here we need to convert given ungrouped data into group data and devise some method to find the mean. Okay, so let us convert the ungrouped data of example 1 into group data by forming class intervals of width. Okay, so 15. So say 15, remember that while allocating frequencies to each class interval, students falling in any upper class limit would be considered in the next class. Example 4, students who have obtained 40 marks would be considered in the class interval 40 to 55. Okay, and not in 25 to 40. With this convention in our mind, let us form a group frequency distribution table. Okay, so here basically we want to convert ungrouped data of example 1 into group data. Okay, so you can see table 13.2. so in table 13.2, here basically we convert ungrouped data into a group data. Okay, so here the class interval 10 to 25, here the number of students is 2, and when 25 to 45, class interval 25 to 40, that is then the number of students is 3. When class interval 40 to 55, then number of students is 7, and when class interval 55 to 70, then the number of students are 6, and class interval 70 to 85, then number of students 6, and 80 to 85 to 100, there are number of students 6. Okay, so now for each class interval we require a point which would serve as the representative of the whole class. Okay, so it is assumed that the frequency of each class interval is centered around its midpoint. So the midpoint or class mark of each class can be chosen to represent the observation falling in the class. So recall that we find the midpoint of a class or its class mark by finding the average of its upper and lower limits. Okay, so if we find the average of its upper and lower limit, average of upper and lower limits of a class interval, then we find the midpoint of the class. So class mark, this is equal to upper class limit plus lower class limit divided by 2. Okay, so class mark, this is equal to upper class limit plus lower class limit divided by 2. And which reference to table 13.2 for the class 10 to 25, the class mark is 10 plus 25 by 2, that is equal to 35 by 2. That is 17.5. And similarly we can find the class marks of the remaining class intervals. So we put them in table 13.3. These class marks serve as our xi's. Now in general, for the ith class interval, we have the frequency fi corresponding to the class mark xi. We can now proceed to compute the mean in the same manner as in example 1. Okay, so with the reference of table 13.2 for the class 10 to 25, the class mark is 10 plus 25 by 2, that is 17.5. Okay, and we put them in table 13.3, and these class marks serve as our xi's. And now in general, for ith class interval, we have the frequency fi corresponding to the class mark xi. Okay, so we now can proceed to compute the mean in the same manner as in example 1. Class interval 10 to 25, the number of students fi is 2, and class mark xi is 17.5, and fi times xi, this is equal to 35.0. Okay, and in class interval 25 to 40, here the number of students fi is 3, and class mark xi is 32.5, and fi times xi is 97.5. In class interval 40 to 55, here the number of students are 7, and class mark is 47.5, and fi xi this is 332.5. So similarly you can find for other classes. Okay, So then total f summation of fi, that is equal to 30, and now summation fi xi, this is equal to 1860.0. Okay, so now we can find the sum of the values in the last column, gives us summation fi xi. So the mean x bar of the given data is given by x bar is equal to summation fi xi divided by summation fi, and this is equal to 1860 divided by 30, and this is equal to 186 by 3, this is equal to 62. Okay, so this new method of finding the mean is known as the direct method. Okay, so this method is known as direct method. So basically, for when we have given a class interval, okay, then we need to first of all find class mark xi. Okay, and then we can use the previous concept that we use for ungrouped data. Okay, and you can find the mean or average of the data, average of the group data. And now let us move to next slide. So we observe that table 13.1 and 13.3 are using the same data and employing the same formula for the calculation of the mean, but the results often are different. Okay, so can you think why this is so and which one is more accurate? The difference in the two values is because of the midpoint assumption in table 13.3, 59.3 being the exact mean, while 62 an approximate mean. Okay, so the 62 is actually approximate mean, but exact mean is 59.3. Okay, so here we can which one is more accurate? So the first one, for ungrouped data, the mean is actually more accurate than the mean by using mean of group data. Okay, so sometimes when the numerical values xi and fi are large, finding the product of xi and fi becomes tedious and time consuming. Okay, so for such situation, let us think of a method of reducing this calculation. Okay, so we can do nothing with the fi, but we can change each xi to a smaller number so that our calculations become easy. So how do we do this? What about the subtracting a fixed number from each of these xi dash? Let us try this method. Okay, so we now try this method. The first step is to choose one among the xi's as you mean and denote it by a, also to further reduce our calculation work, and we may take a to be that xi which lies in the center of x1 x2 ... xn. So we can choose a is equal to 47.5 or a is equal to 62.5. So let us choose 47.5. So the next step is to find the difference di between a and each of the xi's, that is the deviation of a from each of the xi's. Okay, that is di, this is equal to xi minus a, and this is equal to xi minus 47.5. Okay, so the third step is to find the product of di with the corresponding fi and take the sum of all fi di's, and the calculation are shown in this table 13.4. Okay, so here we have three steps. First step, you have to choose one among the xi's as you mean and denote it by a. Okay, and in next step is to find the difference di between a and each of xi's. Okay, and then in third step you have to find the product of di with the corresponding fi and take the sum of all the fi di's. So that calculation are shown in this table 13.4. so you can see this table 13.4. so here we can write the all information by this table. So here class interval 10 to 25, 25 to 40, 40 to 55, 55 to 70, 70 to 85, 85 to 100. Okay, and number of students fi are 2, 3, 7, 6, 6, 6, and class marks, that is the average of 10 and 25, that is 17.5. Average class mark of this interval, that is 32.5. Class mark of this interval is 47.5. Class mark of this interval is for 62.5. Class marks of this interval is 77.5. Class mark of this interval is 92.5. Okay, and here the di, here we choose the value of a is equal to 47.5, and then di, this is equal to xi minus 47.5. This is equal to minus 30, minus 15, 0, 15, 30, 45. And now you can take the in third step, you have to take the product fi and di and corresponding fi, that is fi di. Okay, so if we take product of fi and di, then you get minus 60, minus 45, 0, 90, 180, 27 to 270. Okay, so the total summation fi, this is equal to 30, and summation fi di, this is equal to 435. Okay, so summation fi di, this is equal to 435, and summation fi is 30. And now so from table 13.4, the mean of the deviations d bar, this is equal to summation fi di by summation fi. Okay, so now let us find the relation between d bar and x bar. So since in obtaining di, we subtract a from each xi, so in order to get the mean x bar, we need to add a to d bar. This can be explained mathematically as mean of deviation d bar, this is equal to summation fi di divided by summation fi. So d bar, this is equal to summation fi times xi minus a divided by summation fi, and you can write this is equal to summation fi xi by summation fi minus summation fi times a by summation fi, and this is equal to this is actually mean or average of the data. Okay, so this is x bar, and this is equal to actually a times summation fi by summation fi, and this is equal to x bar minus a. Okay, so x bar, this is equal to a plus d bar. Okay, so mean of deviations, relations between mean and mean of deviation basically is x bar is equal to a plus d bar. That is x bar is equal to a plus summation fi di divided by summation fi. So mean of the group data, this is equal to a plus summation fi di divided by summation fi. That is a plus mean of deviations, that is equal to mean of group data. So now substituting the value of a, summation fi di and summation fi from table 13.4, then we get x bar, this is equal to 47.5 plus 435 by 30, this is equal to 47.5 plus 14.5, this is equal to 62. Okay, so therefore the mean of the marks obtained by the student is 62, and the method discussed above is called the assumed mean method. So this method is known as assumed mean method. So till now we have learned mean of ungrouped data, then we have learned mean of group data. Okay, and lastly we have learned assume mean method. Okay, and now let us move to next slide. So in next slide, here we perform an activity. Okay, so here activity 1, here from the table 13.3, find the mean by taking each of xi, that is 17.5, 32.5 and so on as a. So what you observe, so you will find that the mean determined in each case is the same, that is 62. Okay, and why this is same all the time? So we can say that the value of mean obtained does not depend on the value on the choice of a. Okay, so the value of the mean obtained does not depend on the choice of a. That is why we will find that the mean determined in each case is the same. Okay, And now let us move to next slide. So here we observe that in table 13.4, the values in column 4 are whole multiples of 15. So if we divide the values in entire column 4 by 15, then we would get smaller numbers to multiply each FIs. Okay, here 15 is the class size of each class interval. So let ui, this is equal to xi minus a divided by h. So ui is equal to xi minus a divided by h, where a is the assumed mean and h is the class size. Okay, so if we have a class 10 to 25, then the class size is 15. So h is the mainly class size and a is the assumed mean. Then we let here ui, this is equal to xi minus a divided by h. Okay, so now we calculate ui in this way and continue as before. Okay, so find fi ui and then find summation fi ui and taking h is equal to 15, and let us form table number 13.5. okay, so now calculate the values of fi ui. Okay, so first of all we have to calculate the value of ti, then ui, then fi ui. So class interval 10 to 25, here fi is 2, xi is 17.5, di is minus 30, ui is minus 2, and fi ui is minus 4. Okay, so you can similarly find the values of fi, xi, di, ey, and fi ui. Okay, so if we see this table, then if we add the summation all the frequencies, that is f1 plus f2 plus dot dot dot, so summation fi, this is equal to actually 30. And now if we add fi ui, then you will get summation fi ui, this is equal to 29. Okay, so summation fi, this is equal to 30, and summation fi ui, this is equal to 29. And now let's here u bar, this is equal to summation fi ui by summation fi. And here again let us find the relationship between u bar and x bar. So we have ui, this is equal to xi minus a by h. Okay, so we have this ui is equal to xi minus a divided by h. And now therefore u bar, this is equal to summation fi times xi minus a divided by h divided by summation fi. And you can write this is equal to 1 by h times summation fi xi minus a times summation fi divided by summation fi. And this is equal to 1 by h times summation fi xi divided by summation fi minus a times summation fi by summation fi, that is equal to 1 by h times x bar minus a. So 1 by h times x bar minus a, so h times u bar, this is equal to x bar minus a. So that is x bar, this is equal to a plus h u bar. Okay, so x bar is equal to a plus h u bar. So x bar, this is equal to h a plus h times summation fi ui divided by summation fi. Okay, so mean of group data x bar, this is equal to assume mean a plus length of the class interval h into summation fi ui divided by summation fi. So now substituting the values of a, h, and summation fi ui and summation fi from table 14.5, then we get x bar, this is equal to 47.5 plus 15 times 29 by 30, that is equal to 47.5 plus 14.5, that is equal to 62. Okay, so the mean marks obtained by a student is 62. And now let us move to next slide. So the method discussed above is called the step deviation method. Okay, step deviation method. So we know that here in this method, the step deviation method will be convenient to apply if all the DIs have a common factor. Okay, so this method will be convenient to us to apply if all the DIs have a common factor. And second, the mean obtained by all the three methods is the same. Okay, and the third point is the assume mean, that is a assume mean method and step deviation method are just simplified forms of the direct method. Okay, so they are actually simplified form of the direct methods. So the formula x bar, this is equal to assume mean a plus h times u bar still holds if A and H are not as given as given above. Okay, but are any non-zero numbers such as uy that is equal to xi minus a by h. So let us apply this method in another example. So let us see how to apply this method. So let us see example number 2. So in this example here we have the table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers by all the three methods discussed in this section. So we have given this table, and here we have given percentage of female teachers and number of states or union territory. Okay, UT. So here we have basically given class interval 15 to 25. There are number of states or UT are 6, and when percentage of female teachers are 25 to 35, there are number of states are 11 and so on. Okay, so source 7th All India School Education Survey conducted by NCERT. So here now solve this example. So let us find the class marks xi of each class and put them in a column. Okay, see table number 13.6. So here percentage of female teachers are 15 to 25, 25 to 35, 35 to 45, 45 to 55. And number of states or UT that is denoted by Fi are 6, 11, 7 and 4. And Xi are 20, 30, 40 and 50. Okay, and now for class 55 to 65, the number of states or UT are 4, and if and xi is equal to 60 and so on. Okay, so here we take a is equal to basically 50, and length of the class interval h is equal to 10, and then di this is equal to xi minus a, that is xi minus 50, and now uy this is equal to xi minus 50 by 10. Okay, so uy this is equal to xi minus 50 by 10, and we now find di and ey and put them in the table 13.7. so here if we put them in this table, then you will get di is xi minus 50, that are minus 30, minus 20, minus 10, 0, and ey this is equal to xi minus 50 by 10, that is minus 3, minus 2, minus 1 and 0, and fi xi are 120, 330, 280, 200, and fi di is minus 8, minus 180, minus 220, minus 70, 0, and fi ey these are minus 18, minus 22, minus 7 and 0. Okay, so and so on. Here total number of states or UT, that is summation fi, this is equal to 35. Okay, and here the total here the total of summation fi xi is equal to 1390, and here the summation fi di this is equal to minus 360, and summation fi uy this is equal to minus 36. Okay, so now we can find the mean. Okay, so here from the table above we obtain summation fi is 35, summation fi xi is 1390, summation fi di is minus 360, and summation fi uy is minus 36. And now if we using the direct method, x bar this is equal to summation fi xi divided by summation fi, and this is equal to 1390 by 35, that is equal to 39.71. and if we using the assume mean method, okay, then x bar is basically equal to a plus summation fi di by summation fi, that is equal to 50 plus minus 360 divided by 35, that is equal to 39.71. and if we using the step division method, then x bar this is equal to a plus summation fi ey divided by summation fi times h, that is equal to 50 plus minus 36 by 35 into 10, and this is equal to 39.71. Okay, therefore the mean percentage of female teachers in the primary schools of rural areas is 39.71. Okay, so here we will study on remark. the result obtained by all the three methods is the same. So the choice of method to be used depends on the numerical values of xi and fi. If xi and fi are sufficiently small, then you can use the direct method. Okay, so the direct method is an appropriate choice. If xi and fi are numerically large numbers, then we can go for the assume mean method or step deviation method. If the class size are unequal and xi are large numerically, we can still apply the step deviation method by taking h to be a suitable devices of all dis. Okay, so I stop here this lecture. Thank you very much to all of you.